Hello everyone, welcome to Chapter 4, Welding Principles and Practices. We're going to be talking about basic joints and welds, okay? Now there's going to be several different chapters that are going to go beyond this as well. This is just the basic joints and welds to start with. Then we'll get into reading shop drawings, and then in Chapter 29, and then after that, Chapter 30 will be welding symbols and so forth, all right? Start out, first slide here, main objectives. The 5 basic joints and welds applied to each. Remember, there's only 5 basic joints, okay? How to measure fillet and groove weld sizes. You can read through these on your own. Okay, the 5 types of joints. Very simple. There they are. Butt, corner, edge, lap, and T-joint. Okay, over there on the side it says in Chapter 28, the most common joints will be described in terms of their use, advantages, disadvantages, joint prep, and economy. Okay, and that's an inspection chapter. Joint design, testing, and inspection, so forth. We will get into that later on. Let's cover the basics first. So if you're in your book, go ahead and flip to page 118, Chapter 4. I would definitely highlight underneath types of joints. Beginning of that paragraph, there are only 5 basic types of joints. The butt joint, corner joint, edge joint, lap joint, and T-joint. Shows them all, and then an explanation above that in figures 4-1. Okay. I cannot believe. Wow, it does not show the 4 different types. So, there's a few things that I wish were in the PowerPoint. However, I'm not always able to accommodate because they may not have those. So let's touch on them this way. Sketch 1 is the butt joints where 2 members butt up against each other. Okay. The corner joint, where 2 pieces are on their corner. Edge, pretty self-explanatory, the edge pieces of both. And a lap joint, okay? And a T-joint. Now these are not to be confused, sorry, when we get into fillet welds I'll explain this further on. Let's just leave it at this for now. A lap joint, T-joint, that is on page 118, Chapter 4, okay? All right, moving on. There are 4 weld types. They were also in that same, right underneath there in figure 4-2, same page, page 118, Chapter 4. There's a bead weld, which basically is a surfacing weld, correct? A fillet weld, far right hand bottom corner there. A plug weld, and a groove weld. So, one of the things that I want to help explain is that this is a lap joint, okay? But a fillet weld. So a lap joint to where 2 members are lapping over each other. However, if you notice, it's the same weld, it's the same triangular shaped weld that would be on a T-joint. Same thing, same fillet weld, whether it's a lap joint or a T-joint. A bead weld, as you can tell, that's just for the surface, the surfacing weld itself. Now a plug weld can be several things. It can be, of how it can be classified, I should say. To start out with, say the plug is 2 inches deep. The entire thing would be a plug weld. However, each pass might be fillet weld as we are going around, going up to fill the plug weld, okay? Groove weld is done in a groove situation. So we'll talk a little bit more about this as we're going through. But under page 118, chapter 4, I would make it a point to highlight the bolded items under the 4 weld types: the bead weld, fillet weld, groove weld, and plug welds. Okay, I don't see anything specific that I want to point out on that page. So a bead weld is also called a surfacing weld. Single pass deposits of weld metal used to build up powder metal and to replace metal on worn surfaces. First welds that we do in shop, correct? Just on the surface. Excuse me. Fillet welds are the next weld type that we are going to discuss. Consist of one or more beads deposited in a right angle formed by 2 plates. You take the right triangular cross section due to location placed in weld joint. Okay, let's stop right there. So right here, we've talked about this in other sections or in other chapters as well. We are measuring the size, but it is a right triangular cross section that helps define a fillet weld, okay? It can be measured off of different leg sizes and so forth. However, a right triangular cross section is how we define a fillet weld. As you can tell, I keep saying that for a reason. I really want you to know that it is a right triangular cross section. Right there, okay? It's used on lap joints, T-joints, open corner joints. We will learn the weld symbol as we go further on. It's important to know as you're looking at the fillet weld especially. Let's make note of where they are. Weld face, it's the face of the weld that we're going to see. Okay. The weld root is where the 2 closest members are joined. All right? And I want you to look up the definition of the weld root. When we get into weld symbols, we will be breaking this down even further. However, it's where the 2 members are closest together that are to be welded. The important thing is the leg size. Remember, that's how we size a fillet weld size. We measure the distance from the root to here, half inch, or whatever it might be. At this point, we definitely know what the weld toe is. Okay? Groove welds consist of one or more beads deposited in the groove. Used for butt joints, unprepared with square edges, prepared with bevel or a J groove. If both members are prepared the same, they take the shape of a V or a U and named V or U. Butt joint. Wow, that's getting a little too crazy there. We'll talk about that in welding symbols further on. Okay. But if you notice, look at this, and I said the same with fillet welds. It consist of one or more beads. Okay, so it could be a single pass, which is just one weld, or you may see it referred to as a multi-pass or a multiple pass weld, fillet weld or a groove weld, so forth. Okay. Groove welds are just what it's showing here. In this particular situation, these 2 pieces of material are butted up together, so this is a butt joint. Okay, now there's no angle of preparation on it whatsoever. Now this makes it look like it's 10 inches tall. Again, this is not to scale. A butt joint is a butt joint. It doesn't matter whether it's 1/16 or a razor blade thickness, or if it's 10 inches of steel. If the 2 members come together and butt up against each other, it is still a butt joint, no matter, regardless of the thickness of material that we will be welding. Okay? So in this case, it might only be a real thin material, and I'm assuming so since there's no angle of preparation on the weld at all. So this is more than likely a single pass groove weld on a butt joint. Okay? The root is down here. where the two members are closest to each other. The face reinforcement is this amount of material that goes from the toe here to the thickness. It's the weld face. And the toes of each weld, or the toes of the same weld, but each side has a toe. Okay, moving on. Plug welds are similar to slot welds, used for filling slotted or circular holes. Fillet weld may be made around the veined surface of a joint in hole large, if hole large. Well, that's rather confusing. May or may not completely fill the joint. So let's talk about veined surfaces, okay? How do we define, when you see something like this, a veined surface? A veined surface are the two surfaces, if I have two pieces of material, they're the two surfaces that are touching. So in this case, our veined surface is right here. Okay? Both of these pieces of material in between where the two are. So the veined surface are the sides that are touching. And now if we could weld the entire length of that up around it and not have to weld the whole thing solid. Okay? In this case, here's the veined surface. You're doing a plug weld down into this, tying into the bottom piece as well. Okay? Here's slot welds, plug welds, and then fillet welds. So here's what I was discussing earlier. So let's talk about the difference of a slot versus plug. The plug, we can see it is a true circle, so the diameter is consistent all the way around. So 1 inch would be 1 inch, perfect circle, correct? At this point, more than likely, we've taken blueprint. We've talked about diameter in a full circle versus an oval. Now in the slot, you may see it may be 1 inch in diameter. However, it might be 3, it might be 10 inches long. Where do we use slots? Slots are used on, a lot of times on replacement equipment, whether it be in chutes for grains, like a grain silo, to where the inside liner is made of possibly a stainless steel construction so it doesn't get contaminated. And you may have a slot weld in there that you put you have your base chute in, and then you have a liner that goes over top of it. And then you'll weld this slot weld up because it gives you more surface area to weld to instead of several holes. You would weld the liner in, and then once it wears out, if it gets to the point to where it starts to wear down from abrasion, resistance, or impact or something, you can go in and you can pull the liner out, you can cut it out or air arc it out, and then bring a new piece in and replace the material without having to completely rebuild the entire structure. Liners are used in everything from food products to road construction, heavy equipment, all sorts of things. And some of the liners aren't even metallic. You know, we might build something out of a metallic structure or a metal structure, but then it may have like a ceramic or a ceramic lining or some other special sort of lining, especially in the pharmaceutical world, to keep the antibiotics from getting within our medicine and so forth. A whole world of possibilities there within liners, materials that are designed for that special type of application, okay? So, again, plug welds are circular, diameter is the same all the way around. Slot welds are basically a long oval, okay? Now here's what I was showing you earlier. This is still, if this is welded up to where it's a full thing, then it becomes a plug weld, okay? This one here might be at a situation to where it's only 2/3 the way full, half, all the way full. They're still plug welds. This is a plug weld with a fillet weld on the inside. If you notice, it has a triangular cross section, okay? All right. Design engineer determines the load carrying capacity of a welded joint. It's specified on the drawing. use welding symbols, symbols covered, and chapter 30, which we'll be covering later. This is kind of a little backwards from what I would want it. However, let's talk about it. Groove welds. Okay? Measured and sized by the depth of penetration or fusion into the joint. The size does not include reinforcement on face of root of the weld, generally referred to as a partial joint penetration or a complete joint penetration. No size reference then considered to be a complete joint penetration, partial joint penetration weld designated on the welding symbol. So, first of all, partial joint penetration or complete joint penetration? Let's give you a couple quick examples. Okay? There are several different types, and I want you to understand the concept. If you understand the concept, you should be able to look at anything and fully understand what we're looking at. So in this case, this is our typical V-groove. Each member said it's a butt joint. However, both sides have been, edges have been prepared and cut back to be able for a joint preparation to allow for a V-groove. Okay? This is so that we can get in there easier, a lot easier to weld up. This is very common, what you see as a complete joint penetration. But what qualifies as a complete joint penetration is that the weld has to go and cover the entire complete weld joint. Okay? Now down here, a butt joint again. Let's talk about a partial joint penetration. Say that we don't know how thick this is again. Okay, we're just showing, we're drawing big pictures. Again, they're not to scale. So one of the things that we might be concerned with, or we might want to take note of, say our weld only penetrates to here. Most people say, well, why would you do that? Well, there's a lot of reasons we would do that. Not every weld has to be designed to cover the complete weld joint, okay? Complete joint, partial joint penetration. Let's talk real quick and say, why would we want a partial joint penetration? So we talk about road equipment. I will quite a bit because I've had a lot of experience welding on Caterpillar equipment. So the bumpers, when you put your road grader down, the blade goes along the ground and it helps flatten everything out. It's a really important piece to get a nice flat highway, road base, everything, okay? We have to start there. We have to straighten and flatten this out. Well, what keeps the blade from digging into the ground is sometimes there's these bumpers that sit on top, or on the bottom, I mean, and the blade will come down and it'll sit on the side of this bumper, and it's a big, like a dome disc. All right, and that rides along the ground, kind of like a ski, or like the front of a ski, and it kind of goes along the dirt, and it helps keep that blade from digging deep into the ground. Because if not, if we just put pressure on the blade all the time, it would just keep digging and digging, and then we couldn't go anywhere, and we'd have a whole bunch of holes. So we put it down, and we'll free float it sometimes on certain equipment, and we use those bumpers to kind of help go along the road. Well, if you can imagine, that's rubbing on ground and gravel all the time. So eventually this metal is going to wear down. Okay? So I'm going to do a quick drawing here real quick. Show you kind of what it looks like. Again, I'm no artist. I'm going to give you a side profile. So here's your road grader. Okay? This goes against the ground. But back here off of this is where we have our bumper. So here's a big piece like this. And a lot of times we'll have another piece of material that looks just like that, just like a ski, like I mentioned. Now if we welded this piece, and I'm far enough away now that I know I am going to show it in detail so that we can understand it better. Larger scale, okay? Because it not adjust with the zoom on the camera. So if we come in here and we cut this back and we welded this entire thing solid, then what would have to happen is this would have to wear down at a nice even rate and shear off perfect. Well, in real world that doesn't happen. Usually what happens is this will wear off first, and then it'll come in and it'll start wearing here, and then it'll get and wear into this, okay? So we don't want a full, complete joint penetration in that application. What we want is this. We may want to tack or weld here, only that deep, and then we want one up here as well. So that what happens is as this piece wears down, when it shreds this weld, then we no longer see that piece there. So it's what we call a visual aid or a visual check, and we're going to walk around with a piece of equipment. If we're walking around and we look down and we look at that bumper and see if it's back into what they call the frog, the main part of it, then and that shoe is gone, then we know, okay, that's our visual check. We need to get it fixed real quick. Or we check the wear on that. That's a daily check with most road equipment. It's usually made, this is made of a milder steel, and then this piece is usually made of a lot more expensive, harder steel that was designed for abrasion resistance and impact resistance as well. It's going to wear out possibly 5 times slower than this piece would. This piece might last 5 weeks. This piece, if it was on the dirt, it may last 1 shift. Almost literally. It would wear it down that fast. Okay? So there's different applications of what we're doing. That is a good example of why we don't always need to have a complete joint penetration. Now just because we said, I want to be clear about something here. This could be 10 inches thick, and the angle of prep could be 5. Okay? Just because we said here that typically a V-groove weld is a complete joint penetration does not mean that every groove weld we see means it's a complete joint penetration either. You have to look at the print, look at the drawing, see what it's designed for, and weld it accordingly. In this case, if that's 10 inches thick, it would take a tremendous amount of time to weld that up. It may be insufficient to weld it up. It may be designed just like the shoe that we were talking about, that it might be designed to come apart and fall apart when it gets to a certain point to protect the equipment that we're working with. So again, partial joint penetration, that's all that's required. Okay? All right, so complete joint penetration, V-groove butt joint.